Here's our practice problem with geometric sequences. Alright, it says find the term named in the problem, the explicit formula, and then the recursive formula. Okay, this is a geometric sequence, and we know that because we're multiplying to get from -3 to -9, and then from -9 to -27. So the first thing to do would be to find the common ratio, which in this case may be obvious, but we find the common ratio by dividing two terms that are in sequence. So I'm going to divide -9 by -3. Okay, and so we get +3. And so -3 times -3 times 3 would give us the -9. And so -9 times 3 would give us -27. Okay, so that's our common ratio. Now we take the common ratio and we're going to plug it into our general form. Let's go ahead and find the recursive. So we'll find the recursive formula. So earlier I gave you the recursive formula as being a sub n is equal to r times a sub n minus 1. Okay, because it's the term in front. Okay, and then we have to list what a sub 1 is. Okay, so in this case, a sub n will be equal to r, which we found to be 3, times a sub n minus 1, and then a1 is -3. Okay, and so that would be our recursive formula. Okay, now let's find the explicit formula. Now with the explicit formula, okay, we're going to end up having the general form of a sub n is equal to a1 times r to the n minus 1. Okay, now in this case, we know a1 to be -3, r to be 3, and then to the n minus 1. Okay, so that right there is our explicit formula. Now you may want to have to put times or parentheses here so that it doesn't look like -33 to the n minus 1. Okay, now to find the 12th term, what we're going to do is substitute in. So we'll have -3 times 3 to the 12 minus 1 power. Okay, so for this, we'll end up with a sub 12 is equal to -3 times 3 to the 11th power. Now, 3 to the 11th power is going to be a very large number. So we would end up with a sub 12. Again, here I give some more room down here. A sub 12 is equal to -3 times 177,147. Okay, and then we'll take that number and multiply it times -3, and we end up with -531,441. Okay, so that's actually it's a pretty small term, but that would be our 12th term in this particular sequence.